Hi, my name is Daniel Ayer, and this is my video submission for task 2 in my Visual SLAM assignment for DS685 here at NJIT. You can see here that we're going to make a recording of Stella-VSLAM running on the reference Kitty dataset and a video I made of my own space. I'm re-recording this video because there was a lot of noise pickup in the previous attempts. So let's go ahead and talk about what it is that we are doing. First, I would like to show you the Kitty data set, VSLAM. So I have a Docker module or Docker container that we will go over later. Docker compose up map Kitty. Let's see what happens. This fires up and we can see it running through one piece of the Kitty dataset and creating this little map. And this dataset is a stack of images. You can see tracking was lost, but now it's picked it up again, although it's not generating the map again. But you can see down below that the tracking was lost, regained, lost again. So these are just limitations of the software. Doesn't really look like we're generating more of our map, but we do have this interesting map. Definitely looks like a bit of a, what do you call it, like a street that we would expect. So I'm just going to let this run. If you want to jump ahead, you can. But we're done. Okay, so the algorithm has stopped. You can see it's made this map. I'll go ahead and close this out. Okay, so that's all closed. And that was Kitty running. Let's go check out how it was running. Where's my Docker containers? All right, well, I'll just open Docker Compose. Here we go. Okay. So we have all these various services, and I misread the assignment. I didn't see that we had to run it on the Kitty data set. So I already had a container set up for something else we'll go over in a second, but let's walk through map Kitty service. There's an off-the-shelf Stella-VSLAM iridescence. Iridescence is the visualizer, and we'll go over that later, available. So we pull that down, activated display. We have to enable this, X11. There's an X11 server running on my computer, and you can see here that I've enabled it through the bash RC for any terminal. And I've even put a little note here that says, hey, don't forget, take this out, because my understanding is that this is a security hole that can be used for exploits. But you know, here we are. It's just my network. It's not a big deal. Here is the mount. We're going to mount this location from my internal system up to VSLAM, and we're going to call it VSLAM. The entry point internally in the Docker container once it runs is going to be, again, these examples supplied by the Stella-VSLAM team. And we're going to run image slam. That's a binary that's going to take the stack of images and run it. We just saw that happen, actually. The command runs run image slam. It pulls in the orb vocab, a configuration file, YAML file for the specific camera used to record the images so that we can get an accurate reconstruction. And this YAML file was provided by, again, the Stella-VSLAM team. We point it at VSLAM, Kitty, odometry, grayscale, the data set, the sequences, and the image. This is just the source stack of images that we're going to analyze. And then we're going to kick out, these are all just default, we're going to kick out our results. Our map is going to go ahead and be kicked out here to results, Kitty, map. Now, Kitty here is a modality, so the different modalities have their own folders just for good segregation. So that's what we just saw, and I'm going to walk you through very quickly this map video, which is going to do the same thing, except now our binary is run video slam, not image slam. We have a couple of changes here. We have our configuration file, which I created, our YAML for my phone, Pixel 9a. And then below that is the actual video that I recorded of my room. And you can see here that it has its own modality, video. and it kicks out map message. This is for the logs below. So let's go ahead and run this, and you can see what happens. Here we go. Okay, so we're gonna run our map up. Here is my room. This is my living room slash dining room. This video does not contain green dots. The green dots are the iridescence viewer's overlay of what it is doing and what it is tracking as it goes through. So this is a real-time overlay of the video. The video didn't come like that. Now it's completed, and we're going to go ahead and shut this down. And it has saved our map for us. Let's go back and take a look. Okay. Let's talk about our configuration file real quick. We were asked to create a configuration file for our camera. With the wrong file, we just get the wrong cloud reconstruction. We don't get a map. We were asked to take this equirectangular.yaml and convert it. And you can see here that it has all these frames per second, the dimensions of the images that it's recording, and so on, or I guess of the video frame, and so on in order to run. So here is my Pixel 9a YAML modified. It's still 30 frames per second. This is the video dimensions of my phone. I did try here. This is defaulted to 2000. I tried upping it to higher values in order to get a richer map, but it kind of didn't improve anything. I just haven't rolled it back. But it is the max number of key points that it would track. So I'm unclear as to how this would really affect the performance. But as you'll see, I think the performance was relatively good. Now, where did I get these? Well, there's online documentation to create this calibration script. We're asked to grab a checkerboard printout and then take images of that printout from various angles and orientations in order to reconstruct the proper values for our configuration YAML. I had such trouble doing this. I don't really understand why, but it didn't come out very well when I tried to take a picture or pictures. So what I did is I took a video in the same orientation, same resolution as the video to be analyzed, and I ran that through the various poses of the checkerboard, and then I ran that through FFmpeg to splice it out into 1 second bytes, and that gave me a stack of images that I could use that I thought would be as close as possible in fidelity to the video. This script, if we run this script, boop, went through those images, which you can see here are in my workspace, VSLAM, camera calibration, calibration images. All these frames were ripped out by FFmpeg and produced. And it's detecting corners in most of them. Some of them it can't. Okay. And then it gives me these values here, which are up here. Sorry. In my pixel config. Here we go. Here. They are right here. You can see FX, FX, FY, CX, CY, all, and and all these distortions you can see, excuse me, are fairly low, and these distortion coefficients. So now we have our Pixel 9a YAML configuration. It was modified, and we can run, or we did run, our script, and now I want to show you what we did. So here it's going to grab from Stella-VSLAM results, modality is video, and the map that we created. It's going to read all that in, and then it's going to display it. Let's see how that goes. With, Open3D is what we're going to use. Here we go. So these are the results of the Stella-VSLAM being run on our video of my room. Now I apologize if you can hear this fan that just fired up, but the laptop that I'm using, because I have a laptop, it overheats. Okay, so let's zoom in a little. Where did we go? No, I lost it. All right, sorry. over. Bink. Just give it a second. Here we go. Okay. All right, so we'll zoom in. And does this look like a room? Kinda. I mean, I live here, so I kinda can recognize it, but this is how the room looks. There's a couch that splits the room in half. There's, I think, a TV at one end. There's some. I think this is the hallway actually that it grabbed. If that's the hallway, right? So we can sort of reorient ourselves into this space. That's probably another hallway that it picked up. But I think this is a pretty good reconstruction of a boxy space, right? You can even see some details this way and that way. So, I didn't know anything about this a couple months ago, and now here we have this. I think it's pretty great. I hope you've enjoyed my video submission, and I will see you next time.